Welcome again to electrostatic field. Today with another topic, Gauss's law for electricity. So now we are with the second law here, the Gauss law in our learning map, and we will discuss about the electric flux and how to use Gauss law to analyze the electric field. So Gauss's law states that the net electric flux through any hypothetical closed surface is equal to the net electric charge enclosed within this closed surface. In short, phi E equal to Q enclosed is measured with Coulomb because it is equal to the charge. If we imagine we have this system of two charges and we have some closed surface here, so there is no charges inside, so the total flux is equal to zero. But why this happened? Because we have some flux coming in this surface and have some flux coming out from this surface. And these three lines entered here and these three lines come out here. This means the total, if we sum this one, for example, is Qn, and we have this Q out, then the summation of these two is equal to zero. So this means the flux inside this is equal to zero. But if we have another system here, we have nothing going inside this surface, almost nothing going inside except, for example, this line is coming out from the positive charge and it go in again to the negative charge. So this will cancel. But all the charge, all the lines which doesn't go to this negative charge is not canceled. So this means that if we assume this one is Q1 and this one is Q2, this is negative Q2 because it's negative charge, then QE will equal to the amount of positive charge minus the amount of negative charge where the flux lines will go back to the negative charge. We have some definition here, which is electric flux density D, which we'll use from here after. And D is simply the electric flux density. This is the relation between it and the flux. Flux equal to double integral of the D dot N ds, and is also known as electric displacement vector. Since the flux is measured by Coulomb, then flux density is measured by Coulomb per meter square. The second thing here is the relation between D and E, and simply D is equal to epsilon E, and in free space, this epsilon, of course, will be epsilon naught. And since through Coulomb law, we know that E equal to Q over 4 by epsilon R squared in the direction of R hat, then if we divide it by epsilon, we will get this relation to define D based on Coulomb's. Now, the question is when to use Gauss's law for electricity. And actually, this law is very useful when we have a symmetrical charge distribution, like symmetrically distribute charge over a sphere or over a cylinder.